Hello, this is the polynomial functions video number 8, and we will learn about combining functions. So let's say that we have two functions f and g, and we see this formula right here, f plus g and then that of x. So since we are working with polynomials, we will suppose that f is a polynomial and g is also a polynomial. Now, if we add both of them, adding two polynomials doesn't have much complexity to it. You just add both polynomials. So, for example, if f is equal to x to the fifth plus 4x minus 6, and let's say that g is equal to x squared minus 4x plus 17, then this formula will f plus g and that of x will turn into x to the fifth plus x squared plus 9, which is just basically adding these two and combining like terms. So we have no x to the fifth in the g, so we just have x to the fifth. Then we have no x squared in f, so we just have x squared right there. But then 4x and negative 4x cancel out, so that's why we don't have a term with degree of 1 in the resulting polynomial. And then if we add negative 6 and 17, we get positive 9. So that's how we combine, in this case, two polynomials. So if we get f plus g. However, we can have a slightly more complicated formula. This is called composition. This can be translated to f of g of x. So what you do is plug in x for g. So let's say that g is equal to x squared minus 4, and let's say that f is equal to x cubed minus 3x plus 7. So if that's the case, what we do is first plug in x for g, and we get this same equation back since we just plugged in x, so x squared minus 4. But then now, instead of plugging in x for f, our x will become this whole thing, x squared minus 4. So we would have x squared minus 4 cubed minus 3x squared minus 4 plus 7. And so, as you might recall, here we used to have x and here we used to have x, but now we said that our x is actually g of x, and g of x is x squared minus 4. So this is what composition means. So I hope you kind of get an idea of it. And now we will learn about inverse functions. So a function is the inverse of another function if the composition of the two gives back x. So for example, if we have this and we get that this is equal to x, then we know that they are inverse functions. Let's say that f is equal to x squared and g is equal to the square root of x. And we have f composition g. So g of x, we get this square root of x, and then f of that, we get that it is the square root of x squared, and we get back x. So this means that x squared and the square root of x are inverse functions. Very well. Now, another Another way to know if you have an inverse function is by looking at the points that it crosses. So, for example, if we have, for example, x1, y1, x2, y2, and x3, y3, and we say that a function passes through those points, crosses those points, the inverse function must go through y1, x1, y2, x2, and y3, x3. So that's another way to know if two functions are inverse of each other.